Hi friends, today we are going to discuss about distance and displacement concept. Okay, listen to me. In the chapter motion in a straight line, that is I want to discuss about this chapter, motion in a straight line. Now, what is motion in a straight line? Okay, let us consider a particle which is thrown along this line. Without changing its direction, it is moving along the same straight line. Without changing in direction, this particle is moving along the same straight line. This type of motion we are called as motion in a straight line, motion in a straight line, or we are also called it as rectilinear motion. Rectilinear motion, motion in a straight line or rectilinear motion. Motion of a particle along the same straight line we are called as rectilinear motion. And this motion also we are called as one-dimensional motion. One-dimensional motion. We are also called it as one-dimensional motion. Since the particle is moving along the same straight line, that is, I am assuming that it is the x-axis of Cartesian coordinate system. X-axis. Or if you consider it is the y-axis. Or you are consider it is the z-axis. Whatever it may be, the particle is moving along the only one axis. It is moving along only along one axis. That's why we are also called it as one-dimensional motion. That is, motion in a straight line can also be termed as rectilinear motion or one-dimensional motion. Now, in this chapter, now we are going to discuss about distance and displacement. Those two concepts. Path length. Instead of distance, I want to term it as path length. Path length. I want to call it as path length. And next one, displacement. We will discuss these two. We will discuss these two here. Now, path length, displacement. Instead of distance, I want to call it as path length. Remember that. I am not using the term distance. Here onwards, I want to use the term path length. Okay, what is meant by the path length? The actual length of the path. The actual length of the path traveled by the particle. The actual length of the path traveled by the particle. The actual length of the path traveled by the particle is called path length. That is the definition for path length. Now, what is the definition for displacement? The shortest length of the path traveled by the particle. The shortest length of the path traveled by the particle. The shortest length of the path traveled by the particle is called displacement. Okay, in your ninth standard, you called this path length as distance and displacement as the shortest distance traveled by the particle. Instead of distance, here I want to name it as length of the path. The shortest length of the path traveled by the particle is called displacement. Okay, little later I will give the examples for both of them, path length and displacement. Okay, here what is the SI unit? Nothing but in System International, what is the unit of path length? SI unit for path length. Actually, this path length, it is derived from a fundamental physical quantity, length. Therefore, its SI unit is meter. Similarly, displacement is also derived from which fundamental physical quantity? Length. Therefore, its SI unit also meter. Now, while describing the path length, we are not considering the map, we are not considering the direction of motion. Therefore, path length is taken as scalar quantity. Path length is a scalar quantity. But displacement is a vector quantity. What is meant by the vector? What is meant by the vector? It is a physical quantity which is having both magnitude, direction and also obey laws of vector addition. Here this displacement obey the laws of vector addition. That's why displacement is a vector quantity, but path length is a scalar quantity. Path length is a scalar quantity. Okay, now before going to the examples of these two, I want to give another definition for the displacement. In another manner, not another displacement, in another manner, I want to define this displacement. That is, the difference between final and initial positions of the path length traveled by the particle. Another definition, in another manner, the definition for the displacement is the difference between final and initial positions, the difference between final and initial positions of the length of the path traveled by the particle. Length of the path traveled by the particle. The difference between final and initial positions of the length of the path traveled by the particle. Actually, this definition we are going to use in our examples. This definition, that is the difference between, you must remember this definition. Now onwards, you must remember this definition for the displacement. The difference between final and initial positions of the length of the path traveled by the particle. It is the displacement. Now we will observe some examples on path length and displacement. Here you consider two stations A and B. Two towns or two cities or two stations. This is the path. That is, a road is exist in between two stations. A road is exist in between two stations. Now, I am assuming that A is the origin of Cartesian coordinate system. That's why its position is taken as 0. Its position is taken as 0. Its position is 0. The position of B is 200 meters. That means in between these 2 points, what is the difference in the length, or what is the length of this road? 200 meters. Length of the road is 200 meters. Now a bus or a particle travels from A to B. A particle travels from A to B, from the station A to station B. A to B. Find out its path length. In your ninth standard, you are called this path length as the distance, but here I want to call it as path length. S is equal to, instead of path length, I am using the symbol S. You may take it as X or Y, whatever it may be. Here, for my convenience, I am using S. Now this S is equal to how much? Actual length of the path traveled by the particle. What is the actual length of the path traveled by the particle while it is moving from A to B? 200 meters. Length of the road. Actual length of the path traveled by the particle. What is displacement? Displacement. Instead of displacement, I want to put the bar on S or X bar or Y bar, because it is a vector quantity. It is a scalar quantity. To give the difference between both of them, I want to use bar on this physical quantity. Now S bar, what is meant by the displacement? Final position minus initial position. The difference between final and initial positions of the path traveled by the particle. Final and initial positions of the length of the path traveled by the particle. Therefore, what is the difference between final and initial position? You must remember that in the physics, change or difference, you should take it as final minus initial. Change is nothing but it is always final minus initial. Remember that. Now, what is the final position? Difference between final position and initial position. Final position minus initial position. Here, final position 200 meters and initial position is 0 meters, which is equal to 200 meters. Now you can observe these two, path length and displacement. In this example, both are same. Now I want to discuss another example for path length and displacement. Now you can assume the particle is moving along the same straight line. This is point A and here it is point B. Its position is taken as 0. Its position is taken as 400 meters. Its position is taken as 400 meters. Now the particle again moving back to this position along the same road, but for my convenience I am using this dotted line. Actually, the particle moving in this manner and again moving back to this point C. It reaches to the point C. Okay, its position is 100 meters. The position of C is 100 meters. Now a particle travels from A to B and B to C. Particle. A particle travels from A to B and from B to C. B to C. Now you tell me, what is the path length traveled by the particle? Path length traveled by the particle. Instead of path length, I am using yes. Path length traveled by the particle. Actual length of the path traveled by the particle is called path length. This is the actual length of the path traveled by the particle. From here to here, length of the path is 400. From here to here, length of the path is 300. This is 100. Therefore, this becomes how much? 300. Therefore, from here to here, length of the path is 300. Total length of the path traveled by the particle can be taken as 400 plus 300. That is AB length plus BC length. AB 400 meters plus BC 300 meters. It is 300 meters. Totally it becomes 700 meters. Path length is equal to 700 meters. Now, what is the displacement covered by that particle? Instead of displacement, I am using bar on S because it is a vector quantity. Now, S bar is equal to displacement covered by the particle. S bar is equal to, it is the difference between final position and initial position. Now here, what is the final position of the particle? C. Okay, write down in this manner. Final position minus initial position. Initial position. For this journey, what is the final position? 100 meters. For this journey, C is the final position. Therefore, what is the final position of the particle? 100 meters point. This point is the final position. What is its coordinate? 100. Minus initial position of the particle 0, which is equal to 100 meters. Displacement becomes 100 meters. Distance is 700 meters. Final position minus initial position. Remember that. Now you remember these two examples. I will give the conclusion by using all these examples. Okay, another one. A particle is moving from point A to point B or to the station B, and again it come back. It is moving in the backward direction, reaches to this point E. It is moving in this manner and again it reaches to the point A. That is, a particle travels from A to B and from B to C. From B to C along the same straight line. Remember that. But for my convenience, I want to draw the line in this manner. Here road is exist from A to B. The same road. On that same road, it is traveling and it reaches to the point A again. Now, in this situation, what is the path length covered by the particle? Okay, you can assume its position is 0 and its position is 600 meters. Position is 0 meters and here its position is 600 meters. Now, path length, S is equal to how much? Actual length of the path traveled by the particle is called path length. Actual length of the path. What is its total length? OB plus BA. Sorry, it is A. AB plus BA. You can label it as 0 meters. Total length of the path traveled by the particle. AB plus BA. AB 600 meters, BA 600 meters, completely it becomes 1200 meters. What is the displacement in this situation? What is the displacement in this situation? Displacement means final position minus initial position. Final position minus initial position. Initial position. What is the final position of the particle? A. What is the initial position of the particle? A. Therefore, displacement becomes 0. Here, final position coincides with initial position. Therefore, displacement becomes 0. Okay, in another example here, this is the station A and this is the station B. You will assume it as Hyderabad and it is Vijayawada. Now, there is a road in between these two cities. One road is in this manner. Its length of this road is 300 kilometers. Length of this road is 300 kilometers. And another road is also there here. From Hyderabad to Vijayawada or from the station A to station B, its length is 450 kilometers. Its length is 450 kilometers. And another road, it is about 400 kilometers. It is about 400 kilometers. Now, this is one path, one way in order to reach the station B. This is the second way in order to reach the station B from A. This is the third way in order to reach the station B. Now, what is the path length traveled by the vehicle along the path 1? Along the path 1. Along the path 1. Along the path 1. What is the path length traveled by the particle? S is equal to how much? Actual length of the path traveled by the particle. How much it is? 450 meters. Okay. Along the path 1, I am sorry. This is the path 1. Its length, actual length of the path traveled by the particle, it is 300 kilometers. It is about 300 kilometers. Exactly, it is equal to 300 kilometers. What is displacement? Displacement means final position minus initial position. If you are assuming it is at the origin, then its coordinates becomes 300 kilometers. 0 and it is 300 kilometers. Therefore, final position minus initial position. 300 kilometers minus 0, which is equal to 300 kilometers. 300 kilometers along the path 1. Now, if you consider the path 2, along the path 2, along the path 2, you will consider this path 2. Now, what is the actual length of the path traveled by the particle? 450 meters. Now displacement is equal to how much? Here also final position minus initial position. Now for this path also it is 300 kilometers minus 0 kilometers, which is equal to 300 kilometers. 300 kilometers. Now, if the vehicle is moving or traveling along the path, that is, it completes its journey along the path 3. If it completes its journey along the path 3. Now, what is the displacement covered by that vehicle? Displacement covered by the vehicle. What is this S indicates? Sorry, it is the path length traveled by the particle. Actual length of the path traveled by the particle is 400 kilometers. Now, displacement covered by the particle. For this path, this is the final position and it is the initial position. Therefore, here it is 300 minus 0, which is equal to 300 kilometers. What is its position? 0. Its position is 300 kilometers. Therefore, final position minus initial position, it is equal to 300 kilometers. Now, if you consider this situation, an interesting one here. Okay, I will explain it clearly. Okay, here the two stations A, B. There is no road. There is no road in between the two stations A and B. Along this line, there is no road. Okay, here road is exist in this manner. But when you join these two lines with a straight line, its position is 0 kilometers and its position is 10 kilometers. Now, length of this path is, path 1, length of this path is equal to 20 kilometers. Length of this path is equal to 20 kilometers. Now you tell me, what is the, only the path, okay, only one path is exist. Listen to me. Only one path is exist here. Here there is no path. Remember that. Now, the particle is moving along this path. Along this path, you will not consider it as one. Along this path, the particle is moving. That is, its journey is completed by using this path. The particle completes or the vehicle completes its journey by using this road. Because road is exist only this one. Now, along this path, what is the length of path length traveled by the particle? Path length traveled by the vehicle? Actual length of the path traveled by the vehicle. How much it is? 20 kilometers. Now you tell me, what is the displacement covered by the particle? What is the displacement covered by the particle? Okay. Here another way is also exist. This is, its length is 40 kilometers. Now along this path, if the vehicle completes its journey by using this path, if the vehicle completes its journey by using this path, then what is the length of the path traveled by the particle? Nothing but path length. Actual length of the path traveled by the particle. How much it is? 40 kilometers. Now, if the vehicle completes its journey by using this road, what is the displacement? Tell me the answers for both of them. Now, for this road also, final position and it is the initial position. Therefore, 10 kilometers minus 0 kilometers, it becomes 10 kilometers. For this road also, or for this path also, final position and it is the initial position. Therefore, it becomes 10 kilometers minus 0. Total it becomes 10 kilometers. Now, what is the definition for displacement? It is the difference between final position and initial position of the length of the path traveled by the particle. Another definition, in your 10th standard, which definition we know? Or in your 9th standard, which definition you know? It is the shortest distance traveled by the particle, or the shortest length of the path traveled by the particle. Now here, which is the shortest length of the path? Here there is no road. This is one path and it is the another path in order to reach the station B from A. Does it is 20 kilometers displacement? Because this is the shortest path. Is it is 20 kilometers? No. That's why I am saying that displacement is nothing but the difference between final position and initial position. If you are saying that it is the shortest path traveled by the particle, it becomes how much? 20 kilometers. Is it is 20 kilometers? Does the displacement is 20 kilometers? No. That's why you remember the definition for the displacement as it is the difference between final position and initial position. You must remember the definition for the displacement always. It is the difference between final position and initial position. Therefore, answer is 10 kilometers. Now, another one. Let us consider this is the tower or a building, multi-stored building. From this tower, you will project a stone in the upward direction with certain velocity. You will project a stone in the upward direction with certain velocity v0. As it is moving in the upward direction, its velocity gradually decreases, that we know, because as it is moving in the upward direction, force of gravity acts vertically downwards. Therefore, after it rises to this height, there onwards, it is moving in the downward direction. I am assuming that that particle just deviates from its initial path. This is the initial path. Just deviates from its initial path. Therefore, it follows this path and it hit the ground nearer to the foot of the tower. Hit the ground nearer to the foot of the tower. Now, height of the tower is h. Tell me. And also you can assume this height is x. Above the top of the tower, the particle covers how much height? X. Do you understand this diagram? An object is projected upwards from the top of the tower. It rises to a height x. There onwards, it is moving in the downward direction and it hit the Ground nearer to the foot of the tower. Here the tower is of height h. Now you find out the path length traveled by the particle. Path length traveled by the particle. S is equal to how much? Path length means actual length of the path traveled by the particle. Actual length of the path traveled by the particle. What is the actual length of the path traveled by the particle? This plus this plus this. Okay, you will label them as A or O because it is the initial position. It is A and again it is O. It reaches to the point B finally. Now, what is the actual length of the path traveled by the particle? OA plus AO plus OB. Actual length of the path traveled by the particle. What is OA? X. AO will also X. AO will also X plus OB is equal to H. Now, completely it becomes 2x plus h. Now, what is the displacement covered by the particle for this complete journey? Displacement for this complete journey. What is meant by the displacement? It is the final position minus initial position. Final position minus initial position. What is final position for this entire journey? B. And initial position is O. Now you tell me, which axis we assume it as negative y-axis? That is, if you consider it is a Cartesian coordinate system, this is positive x-axis, this is positive y-axis, this is negative y-axis, this is negative x-axis. Now coordinate here 0, 0. Okay, it is 0. Or you can assume it as 0, 0. Its coordinate is 0, 0. What are the coordinates of this? Negative y-axis. With respect to this, it is the negative y-axis. Minus h or 0, minus h. X coordinate is 0, y coordinate is minus h. 0, minus h. That is final position minus initial position. What is the final position? 0, minus h. Initial position 0, 0. We want to describe the displacement along this line. That's why final position minus h along the negative y-axis only we want to describe. Minus h minus initial position 0. It becomes minus h. Do you understand about this? Final position minus initial position. Initial position is 0. Final position is minus h. Then the displacement. Oh, sorry. Here I wrote it as distance. Not it is distance. It is displacement. Displacement. S bar is equal to how much? Minus h. Path length 2x plus h. Now here we are discussed several number of examples are on path length and displacement. Now, while you are observing all these examples, In one example, we got the value of displacement is equal to 0. But in any example, you will get the path length is equal to 0. Just you observe all those examples. You recall all those examples. No, that path length is not equal to 0. That is, path length never be equal to 0. But displacement may be equal to 0. In one example, you will get the displacement is equal to 0. Just you recall those examples. That is, I think it is the third example that we are discussed. In third example, you will get the displacement is equal to 0. Now, that's why we can say that this length of the path or path length never be equal to 0. Displacement may be equal to 0. Just you observe this example, displacement is negative also. Now path length is negative. No. In any example you get the negative value for the path length. No. We will not get the negative value for the path length. Therefore, we can say that path length is always positive. Always positive. It may not be equal to 0, or it will not, its value does not equal to 0, does not equal to 0, its value does not equal to 0, and its value does not negative, its value does not negative. What is about the displacement? Tell me. Displacement. Displacement is maybe positive, it may be negative, it may be equal to 0. It may be equal to 0. Displacement is maybe positive, maybe negative, maybe equal to 0. Remember that. Now, another conclusion by using these examples in between displacement and path length. Already we made one conclusion. It is path length is always positive. Displacement may be positive, may be negative, may be equal to 0. Displacement may be positive, may be negative, may be equal to 0. Okay. Now, while you compare all those examples, we can say that sometimes in some examples, that is in first example, I think in first example, path length in first example, that path length is equal to displacement, path length is equal to displacement. In another example, that is in second example, path length is greater than displacement. Path length is greater than displacement. If you consider any example that we are discussed, that path length is always greater than displacement. In first example, it is equal to displacement. In another examples, it is always greater than displacement. That's why we can say that the conclusion it is path length is greater than or equal to displacement. Now when we take the ratio of path length to the displacement, path length divided by displacement, path length divided by displacement is greater than or equal to 1. That is, path length is always greater than or equal to displacement. Now, another examples for distance, that is for path length and displacement. Another important example, it is, let us consider a particle. A particle is moving along the circumference of a circle, circumference of a circle. A particle is moving along the circumference of a circle. Let us consider that circle is this and its radius is r. Now it wants to travel from the point A to point B. It wants to travel from point A to point B along this path. Completely it is a circular path. Now it travels from A to B. Only from A to B. The radius of the circular path is taken as capital R. What is that capital R indicates? Radius of the circular path. Now for this journey, find out the path length traveled by the particle and displacement covered by the particle. First, path length traveled by the particle. What is the path length traveled by the particle? What is the definition for the path length? Length of the path traveled by the particle. Actual length of the path traveled by the particle. This is the actual length. Nothing but for this circular path, it is the arc length. Okay, path length S is equal to arc length of AB. Arc length of AB. Now, what is the arc length of AB? I am assuming that here, if the particle travels from A to B, this radius subtends an angle theta at the center of the circular path. Therefore, what is the arc length AB? Yes, it is R into theta. R into theta. Arc length. In your 10th standard in the coordinate geometry, you know about this formula, arc length, R into theta. Okay, you must substitute this theta in terms of radians. In terms of radians. Rs is equal to R into theta in terms of radians. How we will substitute it? In terms of radians. Okay, it is 60 degrees. 360 degrees is equal to how many radians? 2 pi radians. Therefore, 1 degree is equal to how much? 2 pi by 360. Sorry, 360. Therefore, theta degrees is equal to how much? 2 pi by 360 into theta. Remember that, 2 pi by 360 into theta. That is, you must substitute the theta in terms of radians. Theta in terms of radians. Now, 60 degrees, nothing but how many radians? 60 degrees, nothing but how many radians? 1 degree is equal to 2 pi by 360. Theta degree is nothing but 2 pi by 360 into theta radians. It is in radians. It is also in radians. Now you tell me. 60 degrees is equal to how many radians? Which is it is 2 pi by 360 into 60. That is equal to pi by 3 radians. Pi by 3 radians. 30 degrees is equal to how many radians? It is 2 pi by 360 into 30. Theta degree is nothing but how many radians? 2 pi by 360 into theta radians. Therefore, 30, how many times? 12. Nothing but pi by 6 radians. Pi by 6 radians. That is, you must substitute this theta in terms of radians. Now, what is the displacement covered by the particle? For this journey, what is the displacement covered by the particle? S bar is equal to how much? Displacement covered by the particle. Nothing but final position minus initial position. You will take, this is the axis. Any axis, x axis or y axis, z axis. Okay, you will assume it is x axis. Its coordinate is 0, 0. You can assume it as 0, 0. Now, from here to here, I want to consider it as x. Therefore, its coordinates are x, 0. Now, displacement means final position minus initial position. X minus 0. Final position minus initial position, which is equal to x. But in the problem, they will not given the x value. They gave r and theta. That means we want to find out this x in terms of r and theta. How you will find out that x in terms of r and theta? This is A and this is B. It is x. Completely this angle is theta. Now you can drop a perpendicular from O onto this line. Therefore it becomes theta by 2. This angle is also becomes theta by 2. This length becomes x by 2. This length becomes x by 2. Now it is r. It is r. Now you tell me. Sin theta by 2 is equal to how much? Sin theta by 2 is equal to how much? Opposite side divided by hypotenuse. Opposite side divided by hypotenuse. What is the opposite side? X by 2 divided by r. In this triangle, sin theta by 2 is equal to x by 2 divided by r. This implies x is equal to, or x by 2 is equal to how much? R sin theta by 2. This implies x is equal to how much? From this, x by 2 is equal to r sin theta by 2. X is equal to how much? 2r sin theta by 2. 2r sin theta by 2. X is equal to how much? 2r sin theta by 2. Therefore, displacement S bar is equal to x, which is equal to how much? 2r sin theta by 2. Path length and displacement are measured in this manner. Now you must remember that in case of the path length, theta should be substitute in radians. Displacement nothing but final position minus initial position. This length we want to calculate, which is calculated by using this concept. It is equal to 2r sin theta by 2. Remember that. Okay, thank you. I will stop the class from here.